So let's get to the volume, shall we? So the volume effectively is a three-dimensional measure, unlike length, right? So that explains why the relationships sometimes are a little weird. And I'm going to spend like a fair amount of time on the relationships because that is one of the most challenging things. So we're going to start with a cubic meter. Okay, good? So we talked about it before. If you take a cube with a 1 meter side, I'm not going to draw all three of them if you don't mind, all right? So the volume is 1 meter cubed. No questions about that? All good? So another unit that we sometimes use is a liter. So if we take the cube, they are not up to scale, obviously. Where the edge is 1 decimeter or 10 centimeters. 1 decimeter cubed equals 1 liter. Are we clear about that? Bear with me because we're going to establish some relationships. Finally, if we take a cube with a side of 1 centimeter, then the volume will be 1 centimeter cubed. Any questions about these units that we established right now? Again, remember, we just agreed that, for instance, this will be called 1 liter. All good? Now, I have first question for you. So if 1 decimeter is 10 centimeters, right? I can write down this. 1 decimeter multiplied by 1 decimeter multiplied by 1 decimeter equals 1 decimeter cubed equals 1 liter. Any objections to what I wrote? All good, everybody? How many centimeters are in 1 decimeter? Can I write this then? Can I?
Yes.
Yes. What's going to be 10 by 10 by 10? 1,000 centimeters cubed. Right? So in 1 liter, we have 1,000 cubic centimeters. What is the prefix that we use when we talk about 1,000 times less? Go on. Okay, if you're wrong, it's fine. Huh? Go on. Milli, yes. So, 1,000 milliliters. Do you see the relationships? Okay? All good? Now, one of the most common mistakes that I've seen, is, here's the question. I'm asking you a question. How many cubic centimeters in a cubic meter? Hold on. The first reflex is to look at this centi prefix and say, well, it means, 100th part. It must be 100 cubic centimeters. but it isn't. Because how many centimeters is in 1 meter? 100. Okay? So for the volume of that large cube, I can write down this. Does that make sense? You all agree with it? Yeah? We can do that? What's going to be 100 by 100 by 100? 10 to the power of 6. A million. So 1 cubic meter is equivalent to 1 million cubic centimeters. Does that make sense? Yes? Yes? Now, to kind of, finish it up, let's establish the relationships between liters and cubic meters. So, how many, that's kind of a not really challenging question, just checking if you're paying attention. How many decimeters in 1 meter? 10. Before we move on, you all following? So we can write down that 10 decimeters multiplied by 10 decimeters multiplied by 10 decimeters will be 1,000 decimeters cubed, or 1,000 liters. That makes sense? Better? The explanation why we made such a conclusion? So you can say that 1 cubic meter contains 1,000 liters. 1 liter contains 1,000 milliliters, which means 1 cubic meter contains million milliliters. The volume is the only confusing unit that you really need to do math to understand how many, like milliliters in this and milliliters in that. Good? Okay? I basically just expanded this. Question so far? Again, this is the... in chemistry and in medicine, we mostly use mils. In medicine, yeah, you're going to see cc. That stands for cubic centimeter, right? So, and they can be used interchangeably. Mass, realistically, there's a limited number of relationships that we actually going to use. You still have to be able to convert using those centi, milli, and whatnot, okay? But 1 kilogram is 1,000 grams. 1 gram is 1,000 milligrams. And 1 milligram is 1,000 micrograms. Okay? Now, you have to remember that when you go from, let's say you are asked to convert from smaller units to larger units, from centimeters to meters. If you have, let's say, 91 centimeter, it's going to be 0.91 meter. I'm skipping the calculations. What I want to highlight, check this out. Which number is bigger? Just the number. 91, right? So if you go from small to large, the actual number should reduce. If you go from large to small, it should increase. when you're going to be taking an exam and you need to kind of do some conversions, keep it in mind. Make sure that your answer makes sense from like day-to-day point of living. So which one's bigger, millimeter or centimeter?
Centimeter.
Kilogram or centigram? Deciliter or microliter? Microgram or milligram? Milligram. Right. 1,000 meters. One of these three. Say again? No. 2. 1 kilometer. 0.1 meter. 0.01, sorry. 1/100th. 1 centimeter. Okay. Right? It's 1/100th part of a meter. Okay? It's a centimeter. 1 kilogram. This is my favorite. No, because first of all, what does it stand for? Centiliter. So 0.01 of 1/100th of a liter.
0.001.
I'm not going to torture you. There's the people who designed it made a typo.
1.
None of these answers is correct. Think about this.
It's going to be 0.001.
1 centiliter is the same as that. Do you agree with me? I see some confused faces. I'm going to expand it. What just happened? Sorry. So 1 centiliter is the same as 1/100th of a liter. Agreed? Is the same as 0.01 liter. Okay? Now, 0.01 centiliter is the same as 0.01 multiplied by 0.01 liter. Hang on. A centiliter. Do you agree that it is this number? I'm sorry. Yes. This, do you agree that it is that number? Yes. So if you do the multiplication effectively, you're going to have 1 divided by 10,000, which means the answer should be this. That type. That's all. Okay? So far. There is a mnemonic rule which I don't remember. There's a bunch of them. But there is a somewhat, if I may say, simpler way. If you feel like uncomfortable moving the decimal point, let me show you how you can do it in slightly easier way. So you have a unit, whatever it is. It can be gram, it can be liter, it can be meter. Okay? To the left, you do the increasing units. So kilo, mega. I'm going to leave it at that. Okay, so kilo and meg, whatever. To the right, you have the units that decrease the value. So deci, centi, milli, micro. Good? Okay. So let's say your unit is 1 meter. Okay? Kilo is 1,000 times more, so you need to do 3 decimal jumps every time it's by the factor of 10. Okay? So decimal point is here. Which direction did we do these jumps? To the left. So we move that decimal point 1, 2, 3 times to the left. We have 2 empty spots. This, so 1 meter is the same as 0.001 kilometer. Okay? That makes sense? Now, let's say we have 100 millimeters. So we write here. We want to convert it into centimeters. In which direction should we go? How many steps? 1 step by the factor of 10. So we move that decimal point to the left. What do we get? Good? Let's say we got batshit insane and decided to convert 100 millimeters into kilometers. How many steps? Count with me. 1, 3, 4, 5, 6. So we have to move that decimal point 1, 2, 3, 4, 5, 6 steps, right? Okay, so it's going to be 0.0001 kilometer. Choose whatever you prefer. Okay, I would suggest use both to check yourself, you know. So now we're going to move on and talk about equalities and then conversion factors. So these are the examples of equalities. You can use them to move between the metric system units, or you can use them to move between the metric and imperial, or within imperial. Okay, like this. By the way, on the side note, that video that I showed you, there's part 2, which is also hilarious. Okay? I'm not going to read this table to you. I promise, first of all, during the exam, you will need to convert. Say meters to feet, feet to meters, and this and that. Okay? Am I making sense? Do not memorize the equalities. You will be provided them, and if you will need some extra, which I doubt, I will happily Google it for you. My goal is not to force you to memorize stuff that you will forget 5 minutes after you leave the class. My goal is to check that you can use the equalities that you can easily find anywhere else. And out of the equalities stem the conversion factors. So what does this conversion factor mean? It means that 100 centimeters represent 1 meter. And this conversion factor tells you that 1 meter contains 100 centimeters. Those are fractions. Does that make sense to you? So this is another example of conversion factor. 1 kilogram contains 2.2 pounds, or 2.2 pounds contain 1 kilogram. Okay? So, for example, first of all, what is the equality for liters and milliliters? Tell me. 1 liter is equivalent to 1,000 milliliters. Therefore, the conversion factor, this one I'm gonna do for you, next one's you're gonna do for me. So we can say that 1 liter contains 1,000 ml, or that 1,000 ml contain 1 liter. Okay? If you have a question like which one should we use, just keep it in the back burner. Inches and meters. Holy shit. I don't remember. What is it? 39.4 inches. So 1 meter equals 39.4 inches. Okay? What are the conversion factors? What should I write? And the opposite. Very good. Milligrams and micrograms. So that's a nice one. 1 milligram contains 1,000. Remember, the difference between milli and micro is 1,000. So the conversion factors, 1 on top, 1,000 on the bottom, or 1,000 on top, sorry, micrograms, my bad. One on the bottom. Okay? Remember the calipers that you were using on Monday? They gave you the measurement in millimeters. So for instance, there's like, let's say, 49. Let's say you had a measurement of 49.14 millimeters, right? So you can use an equality to go from millimeters to centimeters, and this is what we're going to do, the using conversion factors. So you may not realize, but you use equalities all the time in real life. So for instance, bless you, meters and decimeters. 1 meter is what? 10. So everybody understands the conversion factor for this example. Okay, good. So 18% gold. There's not much of an equality here, but you can say that it's 18 over 100, like gold versus total. That's your percent. Okay? Now this is more useful. 1 gallon of gas. So you can say that 1 gallon can be bought for $2.40, or you can say that $2.40 can buy you 1 gallon of gas. Okay? So, how do you use conversion factors? You need to think about what's given. I'm going to do sort of an extended solution. So, what we know. Yes.
You can just divide by 2.2.
Hold your horses. We'll get there. Because did you grow up with metric system? I want more structural approach for you folks. Okay? So, what do we need to find?
Weight to kilogram.
Kilograms. Okay? So first, let's write an equality. 1 kilogram equals 2.2 pounds. Okay? Now remember, we need to go from pounds to kilograms. Okay? All good? Mnemonic rule that I usually provide. It's not even a rule, it's just saying that kind of sticks. From on the bottom to on the top. So, which unit are we going from? So, using this equality, do you follow? Using this equality, we can derive two different conversion factors. The conversion factor that we need contain kilos on top, pounds on the bottom. How do we know that we are correct? Pounds cancel each other out. Okay? Am I interested in numerical result? Absolutely not. There's one more thing to think about. What is bigger, kilogram or pound?
Kilogram. Or same.
No. Kilogram is bigger, right? Because 1 kilogram contains 2.2 pounds. So your body weight in pounds, since it's a smaller unit, should be more numerically than in kilos. Okay? Does that make sense? Keep it in mind when you're converting. Because if you have like a person who weighs 200 pounds and your conversion results in 440 kilos, you're doing something wrong. Okay. Let's not do all that extensive work. So what we have is 2.44 meters. Which unit are we going from?
Meter to centimeter.
Meters and 2 centimeters. So how many centimeters does 1 meter contain?
100.
Always check that units cancel each other out. Sounds good? Now, what if we need to use, we have to go like through multiple steps. There are two ways to skin that cat. One is to do it in one long row. You can do it totally fine. Another one is to do it step by step, whatever you prefer. Okay? The point is, you will need to use individual conversion factors to go from one unit to another. So, let's solve this example. Okay? What are we given? We have that number. Point 150 mgs. Hang on. We need to know how many pills. So there are two equalities that we can have here. Hear me out. One is this. Sorry. That one tablet contains 50 micrograms. Right? Right? But the dosage that we're given is not in micrograms. It's in milligrams. So we need to write another equality. 1 milligram is how many micrograms?
1,000.
1,000. Everybody's following what I'm doing here. Okay? So, our answer should be in tablets. So we need to go milligrams, micrograms, tablets. Okay? So, first of all, how do we go from milligrams to micrograms? What do we put on the bottom? 1 milli, very good. From milligrams to how many? That checks out. And then from what? 50 micrograms to 1 tablet. Okay? Good? Folks, if you want, I can convert this in PDF and post it in a separate folder. That's not a problem. I understand why you want to see this. That's totally fine. And I can export it as PDF and post it. No problem for me.
But you're going to upload these anyway, right?
Videos, I'm going to upload them on YouTube. The first one is already there. I'm just going to give you a link. Because everybody's using YouTube. It's so much easier. Okay? Now, here, minutes in 1.6 days, right? So we have to go from days to minutes. Let's do it. What do you want to do first? You want to go from days to what unit?
Hours.
Hours. What goes in the bottom?
Day.
How many hours?
24.
It's the second factor. You go from hours to minutes. What's in the bottom?
1 hour. 60 minutes.
Whatever. You can use a calculator. I don't care. About numerical values. Does that make sense? So you can do these calculations and get whatever number it is.
So when you do the calculator, you just multiply the 30.
Yeah. 1.6 by 24 by 60. Yeah. So it's not hard. It's just more. Okay? So you have to go, what is your... You need to identify the from, the original. That's your original, 7.5 kilometers. You basically hear me out, you solving the problem of sorts, how long will it take me to drive somewhere, okay? Because if I tell you that from here to Columbus, it's 120 miles, I don't know, whatever, 100 miles, right? And let's say it's a straight shot and you can go 100 miles an hour, you can quickly say, oh, it's going to take me an hour, right? That makes sense? It's the same problem. You have a distance, you want to convert it in time. Correct? So we start with the distance, 7.5 kilometers. Okay? But your velocity, your speed, is not in kilometers. It's in meters. So you have to go from kilometers to meters. So from kilometers to meters, what goes on the bottom? Kilometer contains how many meters? That checks out. Okay? Now you need to go from meters to minutes. What goes on the bottom? 65 meters that you can walk in a matter of how much time? 1 minute. Does that make sense? That checks out. Well, good. Whatever. I don't care. There's going to be some answer. Again, to your question. What do you do here? You multiply 7.5 by 1,000 and then divide this by 65. You see, we talk about, I'm going to digress a little, not really. We talk about speed, velocity, in miles per hour. Okay? So we say 65 miles per hour. It's the same as 65 miles in 1 hour. Do you agree? In real life, it means that, at this rate, it's going to take us 1 hour to go 65 miles. Or we can say that if we're given 1 hour, we can cover 65 miles. We can write it down this way. 1 hour, and in 1 hour, we do 65 miles. Speed is a conversion factor. A price is a conversion factor. A price of, I don't know, a bag of potatoes, 5 pound, 1 pound of potatoes, I don't know, $1. Means that you have $1, you can buy 1 pound. And if you need 1 pound, you just need $1. Does that make sense? It's all conversion factors. Okay, I'm going to finish density and I'm going to let you out. We're doing pretty good. Density. Mass in the volume. We talked about it. Okay? So densities, higher densities, particles are very close together. Lower densities, particles that are farther apart. Okay? Gas, like oxygen, air. Well, air is not a gas, it's a mixture, but it has a density. And it's super low because molecules are far apart. Liquids, molecules are tighter. Okay? For instance, density of gasoline is lower than the density of water because the molecules are farther apart in gasoline compared to water. Density of mercury, which is liquid as well at the room temperature, or bromine, in the periodic table it's a blue, it's only second, on one of 2 elements that exist in a liquid form at the normal condition, number 35. They are denser than water because molecules are closer apart. Okay? And the density of water is very conveniently measured as 1 gram per ml, or 1 kilogram per liter, or 1,000 kilograms, a metric ton, per cubic meter. A small historical digression. The story of metric systems started in 19th century when the agreement was reached. What is 1 meter? Like, how we decided what's going to be 1 meter? Anyone knows?
1 footstep.
So the line that goes around the Earth, the globe, called meridian, right? Like it goes from north to south and back to north. One of those meridians was going through the city of Paris in France. So a bunch of dudes, a bunch of nerds, decided that they're going to take the length of that meridian, divided by 40,000. And this is going to be a meter. Okay? Then they took 1/10 of the meter, a decimeter, made a cube out of it, filled it with water, and said, that's going to be a kilogram. Okay? We have better definitions now. But my point is that we often refer to the density of water as 1. If the density of a substance is less than the density of water, what's going to happen to that substance? Is it going to float or is it going to sink? Less than water, float. More than water, sink. Okay? Does that make sense? For example, if you have a pot full of water. You take a piece of meat, you throw it in. Is it going to sink or is it going to float? It's going to sink because the density of muscle is slightly greater than the density of water. Now you take pure fat, float, because the density of fat is lower. Okay? So for chemical purposes, we use gram per cubic centimeter, usually solids, just for the most part, or gram per milliliter for liquids. They are absolutely identical. You can use whatever. It's not a mistake. It's sort of a common use. Does that make sense? For the gas, gram per liter, because the density is so low,